Welcome to Mrs. Merkel's physics class. Let's start with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii Spiritus Sancti. Amen. All right, this is our last physics lesson for the year, and we are going to be talking Coulomb's law and vectors. Okay, so you did that homework assignment where you use Coulomb's law, and now we're going to talk about electrostatic force. Okay, electrostatic force is the electric force between charged particles at rest. So, like all forces, the electrostatic forces is also a vector, which what we're going to need to do is we're going to need to do a little bit of review from the beginning of the year. So if you remember from vectors, all vectors have magnitude and direction. So these electrostatic forces will have magnitude and direction. So what we're going to do is we're going to do a little bit of review, and then we're going to go over one problem. Now the one problem has 4 parts, but I'm only going to give you one problem for homework. So think of each part as like a question, and then do it in like 4 separate questions. I think it'll make it easier. Okay? So first of all, for our review for vectors, a vector has magnitude and direction. So take a look at this here. So I've got F1 and F2, and these are forces acting on this object. Now, if you remember from vectors, the way that we add vectors is from tip to tail. So we start here, F1 remains there. Then what we can do is we can slide F2 to the end of F1, and the resultant vector is F1 plus F2. Now, this pictorial way of adding vectors, it's very, it's good because, well, first of all, before we go on, this is 2 forces acting on an object, and this is the total net force in red using the tip-to-tail method of addition. Okay, now this is useful for understanding and for getting a picture in your mind of the resultant force on the object. But as far as the actual specifics and the calculations, we're going to use a different method for adding vectors, which we've done before. And what it is, so for calculating direction and magnitude of a resultant, of the resultant sum, use the method of adding the components of F1 and F2 along the X and Y axis. Okay, so let's take a look and see what that looks like. So if what you remember here, let's say I've got F1, it's this black vector here. Okay, we're going to put that on the along the X and Y axis. So this would be F1X. When you drop this down, this is F1X. And if you go over here to the left, it's F1Y. Okay? So same thing with the resultant vector in 2. Remember, but it's actually F1Y is actually, I know I said I wanted to draw it over here because it's on the Y axis. But for the sake of what we're about to do next, F1Y is actually here because it's a square. Okay, because this is our angle here. Okay, so take a look at here now. F1x is equal to the cosine of theta 1. Okay, so we have theta 1 there. F1x is adjacent over the hypotenuse. That's where that comes from. That's why we have cosine. Okay, F1x is equal to F1, the magnitude of F1, times the cosine of theta 1. Okay, F1y is opposite over hypotenuse. That's why I put the blue line over here. But I wanted you to see it over here so that you can see that it's actually on the y-axis. That's where F1y comes from. So F1y is equal to the magnitude of F1 times the sine of theta 1. Okay, the same thing with F2x. Now, remember here, take a look here. This is, if you put it over here, this is your x. Okay, let's make this our, let's see here, this is theta 2 in there, okay? So F2x is adjacent over hypotenuse, okay, which is cosine, and the y is actually over here if you're looking at it in terms of theta, but this is equal to that. So F2y is equal to the magnitude of F2 times the sine of theta 2, because that would be opposite over the hypotenuse, okay? That's what you have to be really careful with these angles, okay? So let's take a look. So if I was going to add F1 and F2, okay, I would add their components. So what I would do is I would get the Fx total. The total of the x component would be F1x plus F2x, which I forgot the x there. Okay, so the Fx, the total amount of force in the x direction, you add the force of the first vector in the x direction plus the force of the second vector in the x direction. And I did this in red because F1x is the same thing as F1 cosine theta 1, and F2 is the same thing as F2 cos theta 2. So the total force in the x direction is here, okay? And the total force in the y direction, you would add the y components, F1y plus F2y, which is the same thing as saying F1 sine theta plus F2 sine theta 2, okay? So now, if you want to find the magnitude of the resultant force, then you would use the Pythagorean theorem, okay? The Pythagorean theorem says we're going to take the resultant vector, okay, the Fx total, Fx squared plus Fy squared, and take the square root of that, and that will give you the magnitude of the resultant vector, okay? So this is what we have done before when we were adding vectors, but also remember a vector is magnitude and direction. So the direction of F that is specified by the angle that F makes with the x-axis, okay? So if you take a look here, now I drew them on the same one, because remember, this is helpful. This is F1 and this is F2. We have to slide F2 up here to get the F total, okay? F total, that is the angle theta, okay? So your total, your resultant, your magnitude of your resultant vector is going to be the square root of Fx squared plus Fy squared, okay? And the direction of your resultant vector is specified by the angle that F makes with the x-axis. So in order to find that angle, we'll use the fact that tan theta is equal to Fy over Fx, okay? We'll probably have the values for Fy and Fx, so then we'll use the arctan to solve for the angle theta. So that is kind of a review on how we add vectors using their components. Now let's take a look at a specific example. So okay, now let's say that I've got 3 charges, all right? I've got Q1, Q2, and Q3, okay? The information that's given, it's that Q1 and Q2 are 52 centimeters apart, Q2 and Q3 are 30 centimeters apart, and Q1 and Q3 are 60 centimeters apart, okay? Now, whenever you have a problem like this, immediately change from centimeters to meters. And the way there's 100 centimeters in a meter, so I think the easiest way is just take and move your decimal place 2 places to the left. So 60 centimeters is equal to 0.6 meters, 52 centimeters is equal to 0.52 meters, and 30 centimeters is equal to 0.3 meters. Every single step that you complete along the process, I can give you a point just for translating the centimeters to the meters. Okay, so how are we going to, let's see what the question looks like first, and then we'll go about solving this question. This is the last physics question that you will do. So there's going to be one for homework, and then there's going to be one in your final exam, and then that's it. Okay, so let's go through this. They tell us, given information, that Q1 is negative 86 microcoulombs. Okay, so what you want to do is you want to change that into coulombs, because for our equations for Coulomb's law, this has to be in coulombs. So we remember that there is 10 to the 6 microcoulombs in 1 coulomb. So when you change this, it's going to be negative 8.6 times 10 to the negative 5th coulombs. Okay, immediately change that. I can give you a point for that. Q2. Q2 is 50 microcoulombs positive. So change that. It's 5.0 times 10 to the negative fifth. And Q3 is 65 microcoulombs, which turns out to be 6.5 times 10 to the negative 5 coulombs. All right? All right, step one, convert your units. All right, now, that's actually like a pre-step, okay? So now, the question is, they want us to calculate the net electrostatic force on Q3 due to Q1 and Q2. See the purple and the red here? I added those. That wasn't given information. We're going to add those in a minute, okay? So we're going to calculate the net electrostatic force on Q3. So we're looking over here at Q3. So step one, we have to decide which direction that your vectors are going to go in, all right? So let's take a look at Q1 and Q3. Okay, Q1 and Q3 have opposite signs. Q1 is negative and Q3 is positive. So remember, when their signs are opposite, they attract. Okay, so the force that onto Q3 from Q1, it's going to go towards Q1 because Q3 and Q1 want to go towards each other. Okay, so that's why this vector goes in this direction. Okay, step one is just finding out the direction of your vectors. Okay, then we look at Q2 and Q3. So that's this one and this one. Okay, and Q2, and they have the same signs, so they repel. Okay, so that means Q3 wants to get away from Q2. So this is the force on that Q2 makes on Q3. Okay, so that's going to go in. So think about it. If we put it in this direction, it would be like Q3 was attracted to Q2, and it's not. When the signs are both positive, it's not attracted. Okay, so the two forces that we need to figure out is we need to figure out the purple force and the red force. All right, so step one, just decide whether they're going to attract or repel depending on their signs, and draw the vectors that are affected in your problem so that we can calculate the net electrostatic force on Q3. So this is where we're looking at here is Q3. Okay, step one, just decide which direction the vectors are going and draw the vectors into your graph. You get a point for that. Okay, so now let's take a look. Step two. Step two says we're just going to find the magnitude of the two forces, okay? So if you look at the force F13, okay, that's this red one right here. We're going to use Coulomb's law just to find the magnitude. Don't worry about the signs right now. We're just going to find the magnitude. So F13, the force that Q1 exerts on Q3, so it's Coulomb's constant, then times Q3 times Q1, because those are the two charges that are on this, divided by R13. Well, R is the distance between the two. In our case, it's 60 centimeters. Okay, so we have Coulomb's constant times charge Q3 times Q1, all divided by the distance between them, which is 0.6 meters squared. So just write the Coulomb's law down and figure out which two charges you're looking at and find the magnitude. Don't worry about the signs for right now. The magnitude of the force, that Q1 does on Q3 is 140 newtons. Okay, so our other one is the purple one over here. That is between the charges of Q2 and Q3. Exactly the same process. We're going to use Coulomb's constant. We're going to take the charges Q2 and Q3. We're going to put those in. And the distance between Q2 and Q3 is 30 centimeters, which is 0.3 meters squared. Put all of that into your calculator. And the force that Q2 exerts on Q3 is 330 newtons. All right, so now we have got to get the resultant force between these two vectors that are acting on Q3. Well, force Q, the purple one here, everything is in the Y direction. So whenever it's all in one direction, there's nothing that we need to do with that. We'll come back to that later. But look at the force that Q1 is acting on Q3. It's along this diagonal. Okay, so step three, we have to take and break it down into F13 in the X direction and F13 in the Y direction. Now what I did is I blew this up right here so that we could see a little bit better of what was going on, okay? So our angle down here is 30 degrees. Okay, I think that was given in the problem, but if it's not, you have all three sides, you could easily find that that's a 30-degree angle. Okay, so if this is a 30-degree angle, this angle right here is a 30-degree angle. So F13x is equal to cos 30 degrees, okay, because we're looking at this little dotted triangle right here, okay, which is 140 cos 30 degrees, which is 120. So the force in the x direction from the Q1 on Q3 is 120 newtons, okay? That would be this right here, okay? The force in the y direction, because see, look at how it's going this way and then down, is actually negative 70 because this is going down here, okay? You plug that in, that would be F13, which is 140, which we found up here, times the sine of 30 degrees, which gives you negative 70, okay? Step 3, you're going to take the vector that is here, either it's going to be here or here, and you're going to break it up into its x and y components, okay? Step 1, look at their signs and draw the vectors. Step 2, find the magnitude of the vectors. Step 3, for one of them, you're going to break it into the x and the y components, okay? You are almost there, I promise. Every step gets you a little bit closer. Just keep going, okay? Now, step number 4, we need to find the total in the x direction, okay? Well, the total, this one is completely in the y direction, so the fx direction is just the x coordinate of that, which we found the x coordinate to be 120 newtons, all right? Now, the Fy total, though, I want you to take a look at that here. The Fy total is this purple one is in the y direction. So the Fy total, the purple one was 330 newtons, okay? And then the y component of this one was negative 70. So you have to sum up the components in the y direction. So the magnitude for that is 260 newtons, okay? So now we're almost there. You've got the magnitude in the x direction and the magnitude in the y direction, but we have to find the magnitude of the resultant vector. So the magnitude of the resultant vector, we're going to use the Pythagorean theorem. So we're going to take the square root of 120 squared plus 260 squared, add that up, take the square root. The total force, the resultant force when we add these vectors is 290 newtons, all right? You're almost done, okay? So remember, the tan of theta is equal to Fy over Fx, okay? Fy was 260, Fx is 120, so tan theta is equal to 260 over 120, okay? 260 over 120 is 2.2. I took the arctan of both sides, so theta is equal to the arctan of 2.2, all right? And put that into your calculator, and you get theta is equal to 65 degrees, all right? Now, your homework is to find the net electrostatic force on Q1 due to Q2 and Q3. So you're going to go through exactly the same process, looking to see which direction draw your vectors in, okay? That was step 1. Step 2, find the magnitude, okay? Step 3, you're going to break, now this one is going to be along here, so you're going to break this one up into its components, okay? Once you break it up into your x and y components, get a total in the x, get a total in the y, use the Pythagorean theorem, and find the angle, and you will be done, okay? If you can get all the way to the end, I'm going to be very impressed, okay? For the homework, I will give you a completion grade for trying, but you do need to do your best to understand it, because on your final lab, there will be one question like this. Exactly like this, the numbers will be different, and it will either be the forces on this charge or the forces on this charge, okay? And it will be open notes, so I want you to, I'm going to post a solution so that you can go through it again. So you will have this solution from taking notes for today, and you will have the solution on Q1. So basically, all you have to do is walk through the process step by step, and every step that you get in the process gives you another point, Okay, so coming soon will be the final lab, and the final lab is static electricity lab, and you need a comb and 2 balloons. If you don't have those, please let me know right away so that I can mail them out to you if you need them. So you will complete the lab, and there will be, because it's a final exam, I need to have at least one, good question on there. So you will have one of these electrostatic force questions, and there will be also some thinking questions that go along with the balloon and the comb lab. And then that will be your final exam grade, the grade that you get on that lab. There will be more details coming on the lab on Wednesday. I know that this is a long assignment, and I know that the juniors are really busy. So this assignment is not due until Friday. Okay, so that'll give you plenty of time to complete this assignment. I'm hoping to post the lab on Wednesday so that if the seniors want to get that done and out of the way, they can do it, but the lab won't be due until the following Monday. What's most important is you may need to go through this again and pause and write some things down and pause and write some things down, is try to find the electrostatic force. Try to do this whole process for on Q1 due to Q2 and Q3. All right, but I will post a solution to that to make sure everybody's on the same page. But this is what's due Friday. The homework is due Friday. And also then the lab will be due the following Monday. And that is your final exam for physics. And then we'll be done. All right, I think that's all set. If we're all set, if you have any questions, please let me know. Otherwise, enjoy your evening. God bless.